So in this one we're going to have a look at quadratic sequences. So first thing, before we talk about the quadratics, before we talk about the nth term, we can just have a quick look at the sequence below. So you've got 1, 4, 8, 13, 19, 26, and then first thing we want to do is we want to try and work out what these missing values are going to be. Now generally you can work out the next couple of terms without the nth term just by learning the rule or working out what the pattern is. But some questions are going to ask you for the nth term as well, so we will look at that. So start with, you're going to try and see if you can find a common difference. In order to find a common difference, the first thing you have to do is find the differences, whether they're common or not. So you should see here, you've got plus 3, then plus 4, then plus 5, plus 6, plus 7. Okay. What you should notice now is that the differences are all going up in ones. Okay, so if the differences are going up in ones, that means to get to the next difference, you're going to add on 1. Okay, so the next difference would be plus 8, which means to get from 26 to the next one, we're going to add on 8. Okay, which gets us 34. We go back down then to the second difference, so the second difference here must be plus 1 again, which means up here this one must be plus 9, so 34 then plus the 9 will give you 43. Okay, so we've done a couple of things here. The first thing is we found the difference between each of the terms. We've then found what we call the difference between the differences, okay, or the second difference. The second difference was plus 1, so then we were able to use the second difference to work out what the first difference would be, and that allowed us to work out the next couple of terms. So again, that relates just to finding missing terms, finding the next terms or whatever. So hopefully that is okay. That's quite methodical, quite straightforward. Next bit is a bit trickier, and the next bit is about finding the nth term of a quadratic sequence. Okay, so again, we'll use the same sequence. Okay, so say we want the nth term, and we want it for the sequence that we've just used. So say it's 1, 4, 8, 13, 19, etc. Okay, so in order to do this, first thing we need to do is we need to find we need to find the second difference. We've already found the second difference. We know that the second difference from this this sequence we've just used is equal to 1. Okay, so that is the second difference. Now the nth term is actually going to be so the nth term will be in this form, so it'll be in the form of a quadratic. Okay, so really to do this section on sequences, you need to be familiar with what a quadratic is and what a quadratic looks like. Okay, so it's going to be of the form an squared plus bn plus c. Okay, so a couple of things for this. The first thing you want to find is what a is. Okay, and the rule that you just need to learn is that a is half of the second difference. Okay, so if the second difference is 1, that means a is equal to 0.5. Okay, so now we know the nth term is 0.5 n squared plus bn plus c. Okay, so that's the first part of it. Okay, so we don't know what the b is, we don't know what the c is, but we'll work that out in due course. So the second thing now that you do, okay, is you write out the original sequence. Okay, so you've got 1, 4, 8, 13 and 19. Okay, so that's our original sequence. Then what you do is you take away the sequence that is an squared. Okay, so an squared is this next sequence. So if n is 1, 1 squared is 1, and 0.5 times 1 is 0.5, so 0.5 is the first term. Next term, n is equal to 2. 2 squared is 4. 0.5 times 4 is 2. Okay. In the next one, then n is equal to 3. 3 squared is 9. 0.5 times 9 is going to be 4.5. Okay, the next one, you've got n is 4. So then you've got 4 squared is 16 times 0.5 gets you 8. Okay, and then the next one, n is equal to 5. 5 squared 25. Then 25 divided by 2 is going to be 12.5. So just to illustrate where these two sequences came from, this here in the top line is the original sequence. On the bottom line is the sequence an squared. So you've worked out that a is going to be 0.5. For each of these columns, okay, and this is where some people can get confused with this, but in each of these columns, that's n equals 1. So that's for the first term, the second term, the third term, the fourth term, and the fifth term. Okay, so what you've now done is you've now created another sequence. Okay, the sequence an squared. So that's what you've got. What you're now going to do is you're going to take that away. Okay, so you're going to subtract and get whatever's left. Okay, so it's simply just 1 minus 0.5, so 0.5, 4 minus 2, so 2, 8 minus 4.5, so 3.5, 13 minus 8, which is 5, and 19 minus 12.5, which is 6.5. Okay, so now what you've done is you've taken the an squared sequence away from the original sequence to get you a new list of numbers. And now what you do is you find the nth term of that list of numbers. Okay, so we want to find the nth term now of this. So in order to do that, you want to find the common difference. So you should see, if you were to write that out as 0.5, 2, 3.5, 5, 6.5, hopefully you should see that that is just adding 1.5 each time. Okay, so you're just adding 1.5 each time to that. So therefore your nth term of that is going to be 1.5n. And then you have to work out how to get from 1.5 down to 0.5. And to do that, you take away 1. So your nth term of this is 1.5n minus 1. Now that means that your b is equal to 1.5, your c is equal to minus 1, and then what you do is you just put it all together. Okay, so your final answer then will be 0.5n squared plus 1.5n minus 1, and that's going to be the nth term for your quadratic sequence. So what you can do now is you can take that formula and you can just put in any value of n just to check what you got. So if we take test equals n equals 2, you do 0.5 times 2 squared plus 1.5 times 2 minus 1. I just work that out quickly. Okay, you should get 4. And if we just scroll up here, we're looking for the second term of our original sequence. And you should see then that that is 4. Okay, so I would just go down, quickly just do a tick beside that to show that we've tested and we've worked, and then that there is our answer, and that is our nth term for that particular sequence.